This is calculating the empirical formula from the percent composition. So if I know the percent composition, I know that I have in a compound 69.55% oxygen and 30.45% nitrogen. What I want to do is come up with the empirical formula from this. So we're going to ratio the moles in a substance. Now, as you know, the empirical formula is the simplest ratio. So to do this, we're going to assume a mass of our compound and calculate the mass of oxygen and the mass of nitrogen in there. So a really easy thing to assume is 100 grams. So if I have 100 grams of compound, that means, according to this number over here, 69.55% is oxygen, so it means 69.55 grams of oxygen per 100 grams. And so I have exactly 69.55 grams of oxygen. You don't have to show this calculation, but I want to work it through so people understand. I also, if I have 100 grams of compound, have 30.45 grams of nitrogen per 100 grams of the compound. So that gives me 30.45 grams of nitrogen. What we've done then, if we assume 100 grams of compound, we know that we have exactly 69.55 grams of oxygen and 30.45 grams of nitrogen. Now I got to do some erasing. So you don't have to show that part of it. In fact, I erased it because it's not really necessary. You can get directly from here to here, but you do have to say that you assume 100 grams. I need that statement. So now what I'll do is I'll compare moles of these. So I'm going to calculate the moles of oxygen in here, and I know that there's 15.9994 grams of oxygen per mole of oxygen. Put your units in. That's going to give us a value. And down here I have 0.67 grams of nitrogen per mole of nitrogen. By the way, different periodic tables might have slightly different numbers for these molar masses. So I calculate this and I get these two values, the 4.347 moles of oxygen and 2.174 moles of nitrogen. So that's the moles of oxygen and nitrogen in 100 grams of our compound. So these are not whole numbers, so I got to make them into whole numbers. So I'm going to change this to an imply symbol because they're no longer going to be equal, and I'm going to divide both sides, both of these numbers, by the smallest. And all I'm doing is ratioing them into whole numbers. So on the bottom I get 1 mole of nitrogen, and I'm going to box that because they're not divided. And on the top I get 4.347 divided by 2.174. I get 1.9995 moles of oxygen, which rounds up to about 2 moles of oxygen. So my compound, the empirical formula, is 1 nitrogen per 2 oxygens, NO2. That's how you do empirical formula. Now we'll do another one with empirical and molecular. Let's take this compound. It's 92.26% carbon and 7.742% hydrogen. And we're going to give you another piece of information. The molar mass is, and I write molecular weight, is equal to 78.113 0.34 grams per mole. So what I want you to do is calculate the empirical formula like we just did, and we're going to get the molecular formula from this piece of information. So the first step is to find out the mass of each in 100 grams. So we do this, we end up with 92.26 grams of carbon and 7.742 grams of hydrogen. That's how I just did that before. That's assuming 100 grams. Now we convert it. The second step is to convert them into moles. So there's 12.011 grams of carbon per mole carbon. I looked this number up on the periodic table. And up here I have 1.0079 grams of hydrogen per mole of hydrogen. You might have slightly different numbers on your periodic table. So that gives me the following values, which I write down as 7.681 moles of carbon and 7.681 moles of hydrogen. I'm going to put an implies in here right now because I can't have formulas that say C7.681. So I divide both by 7.681, which is the smallest number in both cases, and I get 1 mole of carbon per 1 mole of hydrogen. So my formula, empirical formula, is CH. And that is what we did before. Now I want to get the molecular formula. So I'm going to erase all this. Hang on while I erase, and we'll start with the molecular weight. So we have found out that our formula is CH. That's the empirical formula. Now, to get the molecular formula, what we do is we calculate the empirical weight. This got to add up to 78.113. Well, for carbon, atomic weight is 12.011, and for hydrogen, it's 1.0079. Well, that certainly does not add up to 78.1134. So 12.011 plus 1.0079, and I get a weight of 13.01 grams of carbon per mole carbon, which is not equal to this. This is the empirical weight. This is the molecular weight. So to find out, I got to multiply this number right here, the 13.011, by some factor that will give us 78.11. So I take the 78.1134 and divide by 13.01, and that will give us our ratio. So 78.1134 divided by 13.01, and I get 6.004. Now remember, these are supposed to be whole numbers, so 6 is close enough. So this factor that I've got here, I'm going to call N. N is equal to this 78, the molecular weight divided by the empirical weight, which gives us 6. So that's how many carbons I need. I need CH times 6, only we don't write the formula that way. We go C6H6. And that's how you get the molecular formula from the molecular weight. Okay, so let me recap. This first step, 1, is to get the mass of each element in 100 grams of compound. And that's easy enough to do. You just take the percentages and convert them to mass. The second step is to calculate the moles of each element in 100 grams of compound. The third step is to find the simplest whole number ratio, and that is just dividing smallest number into each. The fourth step is to find the integer n so that we can multiply the empirical formula. So that's the steps you have to do these problems. It's not that hard, but you're going to need to get some practice in, so please practice.